Alright, let's go. Number 10. A physicist spent decades building a model of reality with no time in it at all, only an infinite landscape of frozen moments that never move. British physicist Julian Barbour, working largely as an independent researcher outside traditional academia, published his theory most fully in his 1999 book, The End of Time. Barbour argued that time does not flow, and may not exist as a fundamental ingredient of reality at all. Instead, Barbour proposed that the universe consists of an infinite collection of individual, complete configurations of the universe, each one a snapshot of everything that exists at once, which he called nows. He named the abstract space containing every possible now, Platonia. In Barbour's model, nothing moves between these configurations. Each now simply exists, permanently on its own, and what we experience as the passage of time is only the fact that each now contains memories, creating the illusion of a past leading up to it. Number 9. Two philosophers prove mathematically, using Einstein's own equations, that the past, present, and future must all be equally and permanently real right now. Dutch physicist C.W. Rietdijk published his argument in the journal Philosophy of Science in 1966, and American philosopher Wheeler-Putnam independently published a nearly identical conclusion in the Journal of Philosophy in 1967, an argument now jointly known as the Rietdijk-Putnam theorem. Their proof relies on the relativity of simultaneity, a core feature of Einstein's special relativity, which shows that observers moving at different speeds disagree about which distant events count as happening right now. By chaining together the overlapping present moments of different observers, Rietdijk and Putnam showed logically that every event in the past and future must be just as real as the present, forming a single, static, four-dimensional block universe where nothing is actually flowing, changing, or becoming. Number 8. Einstein's own theory of relativity removed the idea of a single universal now, and many physicists believe this quietly destroyed the concept of time flowing at all. In 1905, Albert Einstein published his special theory of relativity, demonstrating that simultaneity is relative, meaning two events that appear to happen at the same time for one observer can appear to happen at completely different times for another observer moving at a different velocity, with no way to determine which observer is objectively correct. This was confirmed experimentally through decades of tests, including precise atomic clock experiments conducted by physicist Joseph Hafia and Richard Keating in 1971, flying synchronized atomic clocks around the world on commercial airliners and measuring the predicted time differences directly. If there is no universal present moment shared by the entire universe, many physicists argue there is no meaningful sense in which time can be said to be flowing or moving forward at all. Number 7. When physicists tried to combine gravity with quantum mechanics in 1967, the variable representing time simply vanished from the equation entirely. Physicists Bryce DeWitt and John Wheeler, working independently before combining their efforts, developed what became known as the Wheeler-DeWitt equation, an attempt to describe the entire universe using the mathematics of quantum mechanics applied to gravity itself, published through the late 1960s. When DeWitt worked through the mathematics fully, he discovered something deeply strange. The time variable, present in nearly every other equation in physics, completely disappeared from the final result. The equation describes the universe as a fixed, unchanging quantum state with no time parameter driving it forward at all. This result, sometimes called the problem of time in quantum gravity, remains formally unresolved and stands as one of the strongest pieces of mathematical evidence that time may not be a truly fundamental feature of physical law. Number 6. Two physicists showed that time might not be missing from the universe at all, but might instead be an illusion created entirely by the entanglement between quantum particles. Physicists Don Page and William Wootters, then at the University of Texas at Austin, published a paper in Physical Review D in 1983 proposing a striking resolution to the Wheeler-DeWitt equation's missing time problem, an idea now called the Page-Wootters Mechanism. They argued that time does not exist for the universe as a whole, which remains a single, frozen, timeless quantum state, exactly as DeWitt's equation predicted. Instead, time emerges only as a relationship between quantum-entangled subsystems within that larger frozen state, meaning an observer inside the universe experiences time passing only because they are correlated or entangled with a changing subsystem, while the total universe containing both of them never changes at all. A 2013 experiment conducted by physicist Ekaterina Moreva and colleagues in Italy provided the first experimental support for this exact mechanism, using pairs of entangled photons. Number 5. An Austrian mathematician proved, using Einstein's own field equations, that time travel back to your own past should be mathematically permitted in certain rotating universes. In 1949, mathematician Kurt Gödel, a close friend of Albert Einstein at the Institute for Advanced Study in Princeton, published a solution to Einstein's field equations describing a hypothetical rotating universe in which spacetime is curved so severely that it contains closed time-like curves, paths through spacetime that loop back on themselves, allowing an observer to travel into their own past. Einstein reportedly found Gödel's result deeply troubling, reflecting privately on the implications in writings included in a 1949 tribute volume dedicated to his own work. Our actual universe does not appear to rotate in the way Gödel's model required, so this scenario is not believed to describe reality, but Gödel's solution proves something profound. General relativity contains no built-in law that forbids time travel, revealing that the mathematics governing our universe treat the past, present, and future with a flexibility that ordinary human experience insists should be impossible. Number 4. Italian physicist Carlo Rovelli argues that time is not a property of the universe at all, but a byproduct of thermodynamics and our own limited human perspective. Physicist Carlo Rovelli, at Aix-Marseille University, working with mathematician Alain Connes, published research in the 1990s developing what they called the thermal time hypothesis, later expanded in Rovelli's 2017 book, The Order of Time. Rovelli points out that the fundamental equations of physics, at the deepest level we currently understand, do not actually contain a variable that flows the way our intuitive sense of time does. What we perceive as the passage of time, Rovelli argues, actually emerges from thermodynamics, specifically from the fact that we are macroscopic beings interacting with an incomplete, blurred view of the universe's underlying microscopic details, a blurring that generates the appearance of entropy increasing, and with it, the illusion of time moving forward, even though no fundamental clock exists anywhere in nature's basic equations. Number 3. The reason time seems to move forward may have nothing to do with time itself, and everything to do with the arrangement of matter at the birth of the universe. Austrian physicist Ludwig Boltzmann demonstrated in the 1870s that the fundamental laws governing individual particle interactions are completely symmetric with respect to time, meaning they work identically whether run forward or backward, a fact confirmed repeatedly through modern particle physics experiments at facilities including CERN. The only reason time appears to move in one direction, called the arrow of time, is that the universe began in an extraordinarily low entropy, highly ordered state at the Big Bang, and entropy has been increasing ever since, purely as a statistical consequence of probability. Physicist Sean Carroll at Caltech has argued extensively, including in his 2010 book From Eternity to Here, that this means the forward flow of time is not a fundamental law at all, but an accidental consequence of our universe's unusual starting conditions. Number 2. Physicist Richard Feynman showed that certain particles can be mathematically described as traveling backward through time, and the equations work perfectly either way. In 1949, physicist Richard Feynman, building on earlier work by physicist Ernst Stueckelberg, published research showing that a positron, the antimatter counterpart to an electron, can be mathematically treated as an ordinary electron traveling backward through time, an interpretation that produces identical, experimentally verified predictions to the standard forward time description. This reflects a broader property of physics called CPT symmetry, extensively tested and confirmed through decades of particle physics experiments, which holds that the fundamental laws of nature remain valid under a combined reversal of charge, parity, and time itself. If the equations of physics function equally well running in either time direction, with no experiment ever able to distinguish forward time from backward time at the fundamental particle level, it raises a serious question about whether time's forward direction is a real, built-in feature of the universe, or merely a label we impose on a process that is fundamentally symmetric. Number 1. Several leading approaches to quantum gravity suggest that at the most fundamental level of reality, time does not exist at all, only relationships between things changing relative to each other. Physicists working in loop quantum gravity, including Carlo Rovelli and Lee Smolin at the Perimeter Institute for Theoretical Physics, developed a framework beginning in the 1980s in which the fundamental building blocks of reality are not particles moving through space and time, but abstract mathematical structures called spin networks, connected to each other only through relationships, not through any background time parameter. In this view, what we call time is nothing more than a bookkeeping method for tracking how one physical quantity changes relative to another, similar to how a clock's hands changing position relative to the sun's position tells you the hour, without either object experiencing an independent flow of time itself. If loop quantum gravity, string theory, or any other successful theory of quantum gravity confirms this framework, it would mean time, the very thing structuring every human memory, decision, and experience of existence, is not a real ingredient of the universe at all, but an illusion constructed entirely from the changing relationships between things that at the deepest level simply are, without ever truly becoming. If you want to see more videos like this, click the video on screen now, and make sure to subscribe.